All right, I found this rock right off the trail. I found a couple rocks like this. This is the best example I've seen so far of dissolution. It's a chemical weathering process where rain that contains carbon in it, making it acidic, which all rain is acidic. There's no perfect pH, just rain. It will start hitting this rock. One drop will dissolve the spot it lands on. However, rain falls in the thousands and the millions, and so slowly but surely it will start to erode this rock away, just basically dissolving it, because limestone is made out of chemical carbonate, which reacts with the carbon in the water. Found this area, I thought it was a good example of mass wasting, specifically creep. You can see the hill and the sharp cutoff and how everything's starting to slope this way as the earth and all its materials and sediment are starting to push slowly and fall this way due to gravity. This tree, despite the rope's not natural. The rope is for the cutoff area for the dinosaur tracks. The tree is an example of biotic weathering, where the tree will slowly break away that rock face. You can see some pieces of it falling between the rocks, but it's being held up by the roots. And you can even see the roots digging into the rock. So sooner or later, that rock right there will just break off. I don't think it's going to fall because it's already as low as it's going to go, unless it just falls this way with some help with some water. Here, I have a nice example. It's a nice little cliffside, and right above me, I can go even completely under it. You can see I'm under the rock. So this would be Nick Point. Technically, this is a very large Nick Point. Even though water is not constantly running over it, it's still the same process. When the water runs off the top of this little cliff here, it comes down the side of the face here, and it starts eroding the softer rock below the capstone. Capstone is usually a harder rock that's non-permeable, meaning water cannot go through it. And since water can't go through it, like I said, it runs off the side. However, when enough of this cliffside is eroded away from this creek and from that tree and all these roots around it are also helping wear away this rock face, along with the water that falls from the top. That cap rock will fall. And you can see examples of that in rock fall. And I can show you right here. Right there is a broken rock that has shattered when it fell, and that would be considered talus. There are some larger rocks over there. You see that? When it rains, water will run off the side of this face of the cliff. It'll deposit right here in this little creek bed. It's dry right now. That's going to make this an ephemeral stream, meaning that water is only here when it rains due to weather. I do believe it runs off that way because there's more water that comes in from over there. However, it's not, the talus isn't really mounded up here because it's a creek bed, I believe. So the creek bed, whenever it's full, it starts moving the talus and fluvial processes, making it alluvium, meaning it's sediment being carried by water. This is just a close-up of the rocks that fall from the top of this cliff in a process called rockfall. It's a process of mass wasting. You can tell it fell because it broke. You can see the different pieces of the rock shattered, and you can tell that it's from the same rock because you can see the more weathered outer exterior of the limestone. Limestone, when it's more weathered and exposed to elements, it becomes a darker black or a gray. However, you can see the newer limestone, newly exposed, it's like a creamy yellow white color. Really ugly, in my opinion. Normally, you would see more talus here from the process of rock falling. Talus is just the rocks that build up below a point where rockfall is occurring. However, since this is in a creek bed, the creek, I believe, in the process of erosion, starts to carry away the talus and making it alluvium, where sediment is carried in a body of water, such as this creek. You can tell that it leaves behind the bigger rocks because it's not powerful enough to take them. However, in the rocks, considering their size, I'm guessing bigger than that, or maybe even during that, because I don't see many of these other rocks this size that are darker gray. Those rocks would be carried in traction, saltation, and suspension. Suspension is basically this dirt here will be carried away in the water. Very simple. We can all imagine that. Saltation is when these larger rocks will start bouncing along the bottom of the creek bed. And traction is when it just can't lift them up at all, and it just pushes them along. And you can even see where it pushes them up too, but the water does go that direction. So here I could show you the cut bank of the creek. So water, when it's moving in a creek or a body of water or a stream, water on the outside of the stream will move faster than on the inside of the stream, giving it more power of erosion. Basically just being able to cut into this rock. Down the inside of the stream, you can see this, where the rocks that it can no longer carry because it's moving slower. Slower water cannot move as big as objects as faster water. And you can see that a point bar is building up right here of all the rocks that it can no longer carry, depositing there, extending the bank, and cutting in more to this side. This is a spot in the same creek over here at Government Canyon. You can still see some water here, but the water tends to pull up here because on each side of it, the creek kind of goes uphill. So it comes from that direction because if we go that way, it's steeper. However, it will build a pool up here, making it a little pond, and eventually when that pond fills up, it will go that way. However, you can see how the dirt here, the earth, it's very saturated. It's saturated, meaning that it can no longer hold more water, and that is whenever it starts moving along. It starts pushing it out. When the water isn't so full, you can see you can even see the different layers of fullness in the creek. So right here, it's not very full, more full, and then it will go up to here when it's full.